Hey, what's up guys, my name is Cherno. Welcome back to my game engine series. So last time we began our profiling journey by taking a look at how we could actually add a timer to our code to see how long certain functions took to execute. Check out that video if you haven't already. And today we're actually going to take all of that timer stuff, rip it out, completely transform it so that we can look at our timing results in more of a visual way. So instead of just looking at stuff inside IMGUI, if we just take a look at what we had last time, this is basically what we had. We had all of these different functions that we manually added timers to. We added a little name for them, and we were just able to kind of view all of that data here. And if I kind of just pause it, you can see how long everything here took. So Sandbox 2D on update, for example, was 0.141 milliseconds. This is great, and this is a really rough way of just seeing exactly what kind of takes the time in our application. If I go through my run loop, for example, and I just add in different scopes or just in different functions that run loop calls. So for example, application on update, would call something like, layer on update, and maybe I have multiple layers. Maybe I have a particular render queue that goes through render commands or something like that. Once you build up a game and once you have an actual application that does something more than than just drawing like a checkerboard background with a red and blue box, which we will get to eventually, this is really easy and you can really drill that down. Like for example, you look at layer on update. Okay, layer on update takes 10 milliseconds. That's quite a lot. What does that call? Which layer takes the most time? How does that break down? You can keep drilling into that call stack down into kind of that call tree and actually place these timers everywhere and then see everything. That's a great strategy, I'm not gonna lie. Like that's not bad, that's not terrible at all. That's a really good, easy way to do that. You don't rely on any other tools if you do something like that, like you don't need any profilers. That's fine, there's no issue with that. The issue here though is that we have the capability to actually do that, right? I could just take that macro that we made and put it everywhere. But viewing all of this data right now in IMGUI isn't great. For example, I could stop this at any time by clicking on it and then actually pause, basically take a look at these values, but I don't want to see that. I want to see a visual representation of the history of everything that was recorded. I don't just want to see every frame kind of it updating, right, and seeing what's up. No, I want to see everything in a visual way. And I think that looking at profiles visually like this, looking at all these benchmarks visually is probably the best way to do it for sure. Now there are profiling tools like Visual Studio's built-in profiler, which I probably will make a video on in the future. But I don't like to rely on that as my only source of profiling data. I'm not going to say that it's bad. You should use it. It's by far the easiest thing that you can just do that with any running program, right? Just literally just open up the Visual Studio profiler and see how long everything takes. It's a really quick and dirty way to get results out, and it's pretty robust. It's not bad. But this is a completely cross-platform, cross-device, cross-toolset way of doing things because it's kind of integrated with the Hazel engine, and I'm a strong believer of that. I like to be rather independent when it comes to things like this because just from experience knowing that, maybe you're running on an Android device sometime in the future and it doesn't support, Visual Studio's profile just cannot work with it yet. Maybe it's a new device. Maybe it's just, it's just not kind of compatible with the platform that you're currently running on. What if it's a build that you've shipped off to someone? Do you really want to download Visual Studio, hook it up with all of the symbols, and then do all of that stuff? That's a lot of work. You might not be in a situation where you could use that. I talked about a lot about that in the previous episodes, but I don't want to repeat myself too much. But the idea is, I'm a strong believer of having this kind of tool built into the engine. And you'll see that as this series goes on, there's a lot of tools that I like to build into the engine, even though strictly speaking, you could rely on third-party tools for things like that. For example, why build a lot of graphics debugging tools if you can use something like NVIDIA Nsight or RenderDoc, right? Why? Well, because sometimes those might not come through for you the same way that your own tech might, because it's a lot more closely integrated with your own engine. Anyway, let's not talk too much about that. So what we want to do is basically visualize this data. Now, I put up a video specifically about how you can kind of do this visual benchmarking thing in C++. I'll have it linked up there. Make sure that you check it out if you haven't already seen it, because that is like a 18-minute video that literally from scratch in a C++ application with no other code at all takes a look at how we can actually build up this system. And I wrote a bunch of code in that episode, or it wasn't really an episode, but in that video I wrote a bunch of code. I made a gist out of it, put it on GitHub. We're gonna literally copy and paste that gist and then integrate it into Hazel. So that was kind of the whole point. And in the future, I actually want to continue on with doing kind of, I guess, videos in that style. So what I'll do is I'll make like a standalone video where I'm just like, okay, here's a deep dive of looking at, you know, I don't know, like batch rendering or something like that, right? In OpenGL, let's just say, for example, right? I'll kind of have a video standalones for that, because that way anyone who wants to integrate it in their own engine, anyone who's not following along with Hazel or the Game Engine series, doesn't need to deal with all of the confusion of, okay, well, great, this guy Cherno is integrating this batch rendering into his engine, which has a billion other functions and a billion, like a completely different structure than what I'm used to. I want to know how batch rendering actually works, for example, right? So that's why I like making standalone videos, because they just tend to help a lot more people, and they're a lot clearer than kind of having to look at something like Hazel and then integrate it into an engine, because there's kind of two steps to almost everything we do here in Hazel. Step one is, what is this technology? What is this technique? What are we actually doing? What is this structure? And then once we know that, once we know how it works, once we know that we want it, how do we integrate it into Hazel? There's always kind of the understanding and the integration part. And so I want to make the Game Engine series a lot more about integration, and then I want to make standalone videos about actual kind of implementation, we'll say, or actual, I don't know, understanding and teaching. So hopefully that makes sense. Anyway, I don't want to talk too much. Make sure you check out the videos I've linked up there, specifically that one about visual benchmarking, because we're going to be just taking code from that. Our goal today is just going to be a very, very simple version of kind of what we achieved in that video, but inside Hazel. And then I think next time we'll go through and actually discuss how to use that kind of instrumentation timer and the whole instrumenter class that we'll take from that gist and integrate it properly throughout the whole engine, because there's just going to be too much stuff to discuss in this episode. First of all, I want to thank all the patrons that made this series possible. Patreon.com/Cherno is the best way to help support this series. It wouldn't be here without those people, so I'm really, really thankful to everyone there. If you like this series, if you like what you see right now, then go to Patreon and pledge at least a little bit, because that, being able to kind of do that is what lets me do this full time. Currently, like YouTube and like Hazel and all of that stuff is my full-time job. So all of my kind of income, I guess, is coming from things related to that, which is kind of scary in a way, because, you know, it could just disappear any moment and there's no kind of stability, but I'm willing to kind of take that risk and to work on that, because I'm really passionate about this technology. I really want to make the best videos on YouTube to do with game engine programming and just like game development, I guess, and all the tech behind that. And there's too many ideas in my head right now that I want to get them all done, but it's kind of hard because there's so much to do. And anyway, the point is, if you like what you see here and you want to see more of it, then please help to support the series to get access to the 3D version of Hazel, which I haven't actually worked on in a while, but I'm going to get back to that soon. There's a Vulkan version of Hazel, which I'm working on, which I probably will release probably on GitLab or something like that, just because it's a bit more lenient with some features that I actually want. And then there's also, I'm trying to do weekly devlog videos, specifically they're Patreon exclusive videos. Really easy to get into that. It's like $3 a month and you get access to all of them, the whole backlog, as well as any new one that comes out. And that's going to just cover what I kind of do all week, because I want to kind of stay accountable to what I'm actually doing all week and plan my weeks better. And so that's going to help with that. Anyway, let's dive into this code. Let's take that instrumental code and get it integrated into Hazel. So just going through our current code that we had this timer class. This is basically the gist of the timer class. It's funny that I say gist because it's literally on gist. But what I have here, let me just make this a little bit smaller so that we can see all of it. What I have here is a gist. I'll link this in the description of the video. Or in fact, if you go to that visual profiling or visual benchmarking video that I made and that I linked in the top right corner, that video has a link to this. So just go there if you're interested in this specific code. What this is like a basic instrumentation profiler. What this does is basically gives you a static class called instrumenter, which writes out into a JSON file basically every function or every scope that you profile. And then that way we can load it into something called Chrome tracing, which is this little tool that comes with Google Chrome. It's actually anything that's based on Chromium. It actually will have this as well. So I think Opera and some other browsers probably will have that as well. So you can just go to kind of Chrome tracing like that, and then you'll just be greeted with this kind of tool, and you can drop in a JSON file into that tool, a JSON file that will be generated by this class, and you will be able to visualize like a timeline of all of the different timings that you've actually gathered throughout the runtime of your application. So that's kind of the idea. Again, if you want more info on that, just check out that linked video that I made. But yeah, like we're literally just going to copy this, probably up to like here. And then if we go to Solution Explorer and then Hazel Core, this probably isn't exactly a core thing. I don't really like, I might make a folder called debug because this is fairly debug specific. In fact, I will make a folder called debug. The reason is you should never use this in the distribution of your application. Like this is something that is definitely for development purposes only. It's header only as well. So you can literally just, like, you should be able to just paste this in like I just did. And it should just compile and it should work and everything should be fine. So that's what you can do. What I'm gonna do is, because again, this code is something that we just kind of compile once and we forget about. In fact, we don't need this like at all. I might write some macros here first, but you can easily just include this into your PCH. In fact, that's probably the best thing to do. So what I'll do is I will include it into my PCH. And then I'm going to debug. And then I'm going to, and again, you could easily just shut off the whole thing if you know, like you could put the whole thing behind an if-def or something like that if you really, really didn't want it to be compiled at all in distribution builds. But it's probably easier to still have that code, but just, you know, shut off any kind of usage of it by using macros. So what we want to do, and the way this works, you really should check out that video again if you're interested in that. But basically, what I like to do is hz profile, right? So if hz profile is turned on, and this is something that, again, where you want to set this up, you probably want to make some kind of, and we will probably do this in the future, make some kind of configuration file that kind of just has all of the macros that you've configured a certain way. If we check out, what was it, like core.h, right? Like we have a lot of these macros here. We've got enable assert, stuff like that. You don't want this scattered around all of your application, obviously, because if I want to, for example, change whether asserts are enabled, change whether profiling is enabled, I have to go hunt a bunch of files to figure that out. I don't want that at all. There should be like a central file like that's called like core config or something like that, .h, that just has like, you know, stuff like profiling, define profiling 1, you know, define, and I know that's not spelled correctly, but anyway, define, you know, asserts 1 or something like that, just so that you actually know what's up in a single file. So that's something that you should do. We're not gonna worry about that just yet, but if hz profile, so if profiling is enabled, then what I'm gonna do is write a macro that says hz begin, well, we'll probably say hz profile. Okay, what's the actual macro going to be called? Let's see. So hz profile function, right? So hz profile function is going to be for functions. We'll also have profile scope. So I guess profile begin session is fine. So hz profile will be kind of the beginning. That's what you kind of expect. We'll have an end session as well, and as you can see, if profiling is disabled, these will all just result in being absolutely nothing at all, because we don't want them to be, we don't want them to get compiled at all. So session's going to need a name, end session probably isn't, function's not going to need a name, and profile scope will. Okay, so that's what we end up with, and then this will simply just be, let's see, so we need to put this behind the Hazel namespace. So namespace Hazel. We go down here, there we go. And then we'll just do Hazel, so we'll kind of write these the same way that we did with log.h, where we basically just had this, right? So Hazel, instrumenter, begin session, I think, and then name, and I guess we will probably, so this will output to a file, I think, so instrumenter begin session, so that's not static, we'll have to fix that up. But yeah, we have a file path here. So what I will do is probably force this to be written to a file path. So name and file path will go into here, and then I think this is just instrumenter get.begin session. So instrumenter get will just create a static instance like that and then return it, which is fine. We'll just do the same thing here for end session. So end session with, I don't think we need anything for that because we can only have one active session, yep. And then profile function will basically do what profile scope does. We'll have that in a minute. I guess I'll fill this out. It doesn't really matter, but this is just to avoid compiler warnings with macros being used with the incorrect number of arguments. It'll still compile though, even if we did have the wrong amount of arguments here, because you can really put anything you want into a macro. Okay, so profile scope. So this is the meat of everything. So this will just basically start up an instrumentation timer. So instrumentation timer. We'll have to give it a name. Now you probably want to append this with line or something like that to give a unique name. I'll have to test this out because as someone I think pointed out in the comments, the hash doesn't really work with MSVC. Potentially you might need to write another macro, which basically is just like, you know, some kind of combination thing that basically likes to like combine things, kind of like that. Because like there are certain macro tricks that you need to know for Visual Studio, and I always look them up and then use them and then forget about them. So I think assertions, probably need to use them. We don't really have a good assertion. We need to revisit assertions at some point because they're not very robust. And I was working on Hazel Dev recently, and I just realized that asserts can't even be used with no message. Like you have to write an assert with a message, otherwise it doesn't compile, which wasn't great. So I had to kind of refactor the whole assert system. And in that time, I had to use a bunch of hacks to get around MSVC's macro processing. But anyway, so this might not work is my point. Like this might actually, our goal here is to kind of, when we use this, right, when we use HZ profile scope, right, let's just say we were to use it twice like this. So, you know, I'll call this like A, and then we'll have another one, which is like B, right? So at the moment, this wouldn't compile. The reason being that what this does, obviously, is it would create, well, if we didn't have the line, it would just create this, right? And then it would try and make it again. But then obviously they're both called timer, and that means that we have the same variable. So our goal is to basically take the line number, which is like 108 in this case, append it here so we have timer 108, and then this would be called timer 109. And then you can see we get a kind of unique name. That's the goal of why we want to use this whole line thing to begin with. But again, it might not concatenate those two strings correctly. So we will see what this actually results in. And we can do that by just pre-processing to a file. Anyway, let's get on with this. So HZ profile function will basically do profile scope, but it'll use the func sig, which is the function signature, as the name. So function signature gives us basically the complete name of a function. So for void stop, it would give us something like void cdecl, because it also gives us the calling convention, void and then stop, stop and then void for the parameters because there are none. If there were parameters, you know, it would give us the parameter arguments like this. So this actually, oh, and also it would give us the namespace. So it would be like Hazel instrumental stop, obviously. So this is basically what it would give us, which is kind of nice to have a name like that automatically generated. There is also one called function. These are all kind of built-in macros into, I think they're in the C++ standard, so they should be on all compilers. In fact, yeah, they're definitely on all compilers, but I'm not sure if they're strictly in the standard or not. But anyway, the point is, this would give us just, I think, Hazel instrumental stop. I'm not sure if it gives us all the namespace info, if it just gives us, it should, right? So maybe it'll give us this, which is not great because we don't know which overload it is. So if we have multiple stop functions with different, like we can't have different return types, but if we have different arguments, for example, we wouldn't know which function it was. So having the func sig, right, the function signature, just gives us a little bit more kind of precision as to which function it is by just giving us a more verbose name, I guess, for the function. Okay, anyway, so this is what we end up with. That looks pretty good to me. Again, this is suspicious. We'll investigate that. But I think everything else looks pretty good. Okay, so this is if profiling is enabled. What I'll do is I'll just enable it like that for now, for testing. I'll just tab this across because I like to, and just you like to find me on that. Okay, cool. So I think that's it. That looks pretty good to me for a first pass. Okay, so now we can get rid of this timer that we have here and profile scope as well. We'll just get rid of everything that we kind of used here, which means all of this kind of profile results stuff gone. And then, so profile scope we'll replace with just HZ profile function, right? And we don't need this at all. HZ profile function, we'll do on-IM GUI render as well. We can do on event, but it doesn't really matter. And then we actually did profile scope here, so I guess I'll do HZ profile scope for all of these things. And they should work. It's saying that, yeah, see that doesn't, I don't like the way this looks here. It might not really work. Anyway, it's saying that okay, so, oh, of course, I forgot to pass in the name. So this is where we pass in the name. So now this should probably be better. Because we obviously need to actually construct it with a name. Okay, good. And then the other thing we need to do, obviously, is begin session and end session. So that is difficult to decide where you want that. Entry point potentially is a good place to do that. What I'll do is I'll get rid of this initialized log and also hello, because we don't need it, we don't need this. What I'll do is, it's quite common for us to, so create application, return new sandbox, pushes layers and stuff. This is like the initialization part, and then this is obviously the run part, and this is obviously the shutdown part. So what we can do is just add a little HZ begin HZ profile begin session. This will kind of be the startup session, which we can, you know, put it into Hazel profile startup.json. And then we'll have the runtime version, which is just Hazel profile runtime.json, and then we'll have a shutdown one as well, right? So we kind of are profiling everything here, all the different stages into separate files, so that if we wanted to check out the kind of startup performance and how long it takes to load everything, we can do that. But then also we can obviously do the runtime separately. So this is basically what we end up with, and I'll kind of split this up. So we have kind of our begin session for the creation, which is startup, and all of the, it's basically everything that in this case would run in on attach, right? Which for other things, like I'm thinking sandbox app, for example, you know, on attach was doing quite a lot of stuff. So like all of this stuff, right? Well, actually the constructor was doing this, which is basically the same as on attach, because it's going to be running over here before the layer gets pushed, I think. So again, that would all be stuff that we put into this Hazel profile startup.json. And then, yeah, this runtime stuff, everything in the runtime would get pushed into that, which is like our whole kind of rendering loop and everything. And then shutdown, again, would also be recorded separately into a separate file. Now, you probably want to change this to be the name of your application. You know, when you create an application, when you include this entry point file into your file, into your main CPP file, you probably want to customize certain things. This is stuff that anyone can add in the future. I'm not going to worry about it too much. For now, we'll just keep it as this Hazel profile, blah, 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 to keep things simple. Okay, this should now work. Let's just run this, compile it, run it, and see what happens. Okay, so we got a bunch of, okay, these are all in sandbox, I was going to say. We got a bunch of compile error messages because, of course, I forgot to get rid of that entire GUI block of code that we should have gotten rid of. Let's see if we get anything now. Okay, good, it's running. Okay, cool. So it seems to be running. Everything seems fine to me. Let's just close this and see if we got our profiles and if everything worked out successfully. Okay, so here we are inside the sandbox directory. Here we have Hazel profile runtime, shutdown, and startup. So we have all of these. You can see the runtime one is significantly larger, which is what we would expect since it's a running application. If we now open up Chrome tracing and we take a look at runtime, which is probably the only one with actual data, then you should see a visual profile, which is pretty cool. So if we kind of zoom in here, then we can see everything that happens. And these controls are a little weird, by the way. They look kind of smooth and weird. Not really used to this. This is weird. And my WS keys aren't working. Have I done something weird with my keyboard? I don't know. Anyway, the point is, yeah, this is super laggy and weird. Anyway, so we have, you can see sandbox on update, for example, which shows that this particular on update function, you know, took 0.325 milliseconds, and that was the actual sandbox on update. We have camera controller on update that it calls. We have this renderer prep, which is a specific kind of, I guess, scope that I profiled. And then we have renderer draw. So you can see how cool this is, right? Being able to see all of this stuff visually. And then we obviously have what's this? This is on IMGUI render, which gets called after. Then we have a huge break, and then we have the next frame. So this is pretty cool, right? We're able to see this stuff visually now instead of kind of, you know, all kind of running real time inside IMGUI. So definitely very cool. Now, obviously we want to go through and instrument our code a lot more, which basically means we want to add these profile functions everywhere, not just in kind of the sandbox application, because that way you can see that we only get to see certain kind of sections here. But yeah, you can kind of see the point here. There's that camera controller on update that we added in kind of manually, and then that's followed by sandbox on update, okay? And you will notice that sometimes, I think it's happened here, we'll kind of get into that more when we get into it more, but yeah, like, so these two have the exact same start time. And the reason that's happened is because like the timer essentially isn't precise enough to know the difference between, like, we've asked the timer for the current time twice in succession very quickly, and it hasn't been able to update the time, so we get identical start times, which is not correct, because clearly in real life, you know, Sandbox Studio on update happens slightly before camera control on update. So that's happened here, right? You can see HZProfile function, the start time, which happens immediately. If we look at HZProfile function, goes to profile scope, goes to instrumentation timer, and then we have a start point here. We ask it what the current time is by just running this now function and then getting that time point. We've basically gone ahead and called now twice quickly, right? Like that, because that's the code that runs here. And then straight after we do that, we ask it to profile scope, which again starts a new instrumentation timer and gets the current time point, the starting time point. Now, what we need to do is either use a high resolution timer, something like a platform specific timer, like query performance counter or something like that will probably be good enough. Or you'll need to write a little system that basically ensures that every time you ask it for the current time, it gives you like a unique value, which is something that we might do just because it's quick and dirty and it gives us everything we want without having to, you know, write specific timers per platform, and even that isn't guaranteed to 100% work. Anyway, apart from that, everything's looking good. So that's kind of going to wrap it up for today. Next time I want to go through the rest of our code base and see where we can kind of letter this stuff into. There's not too much interesting data to look at now. Keep in mind that, like, there probably won't be interesting data to look at this stage in Hazel's development. We'll fill this out a lot more, obviously, but in general, right, you know, this takes 0.4 milliseconds. Like, everything is quite fast, and a frame is significantly longer than that, probably because it's trying to do VSync or something like that. You can see that a frame from here to here is about 13 milliseconds. If you had to actually do it from maybe the start of the frame to the start of the frame, you can see, yeah, 14 milliseconds. Could be about 16, which is probably, you know, 60 FPS, which is VSync. So that's probably what's happening. But in general, that is our visual profile, which is pretty cool. I think if we look at startup or shutdown, we're not going to see anything at all, because we haven't obviously added any instrumentation into there whatsoever. So we'll definitely fill those out as well in the next video. Anyway, I hope you guys enjoyed this video. Please hit the like button if you did. Don't forget to help support the series and my YouTube channel on Patreon. And next time, we'll kind of use all of this stuff that we've integrated into our engine now to actually get some meaningful data out of it. And that way, in the future, when we do some things, we'll be able to actually see how fast things took. I will see you guys next time. Goodbye.